Hello students, welcome back. In our last video, we have seen about total number of selections and combinations. In this video, we will practice some problems based on number theory. These questions are important because in many competitive exams, they are being asked as such. So we will see how to deal with this kind of problems. Okay, now let us see how to solve problems based on number theory. In that we will first of all learn how to find out the total number of divisors of any particular number. So if there is any particular number n that can be represented as p1 power alpha, p2 power alpha, pk power alpha. So what we are doing is we are breaking this number n as a product of primes. Suppose if I have number 24, then the 24 can be broken as product of primes as 2 power 3 into 3 power 1. Now here there are 3 2's, 2 into 2 into 2, and 3 is repeated once. Now if I want to find out the total number of divisors, that will be given by number of ways of selecting 0 or more objects from the group of identical objects. So there are 3 identical objects here and there is one object here. So if I want to select 0 or more objects out of this 3 identical objects, that will be given by 3 plus 1. And if I want to select 0 or more object out of this one particular object, then that will be given by 1 plus 1. So if I want to find out the total number of divisors of any particular number, then I will represent them as a product of primes, and then I will add 1 to all the powers and then I will multiply. So alpha 1 plus 1, alpha 2 plus 1 into alpha k plus 1. So I will increase all the powers by 1 and then multiply. This includes 1 and n also. The total number of divisors will include, this formula will include 1 and n also. All the divisors excluding 1 and n are called proper divisors. So if you want to find out the total number of proper divisors, that will be given by this formula minus 2. So alpha 1 plus 1, alpha 2 plus 1 into alpha k plus 1 minus 2. So basically you will exclude 1 n itself. So you will get the total number of proper divisors. Now let us take an example. Suppose if I take a number 12, that can be written as 2 power 2 into 3 power 1. So total number of divisors will be given by 2 plus 1 and 1 plus 1. So that is equal to 6. Now let us count the divisors. What are the divisors? The divisors will be 1, 2, 3, 4, 6 and 12. These are the 6 divisors. If I want to find out the total number of proper divisors will be given by, I will subtract 2, because I will subtract the number 1 and number 12, 1 in itself. So the total number of proper divisors will be given by 4, and the proper divisors will be 2, 3, 4 and 6. Now if I want to find out sum of all the divisors, then what will I do? If I want to find out the sum of all the divisors, again you will represent the number as a product of primes, and then you will use this formula. The sum of divisors of n is given by 1 plus p1 plus p1 power 2 plus p1 power alpha 1. So what you will do is basically you will start from p1 power 0. This 1 is basically p1 power 0. So p1 power 0 plus p1 power 1 plus p1 power 2 plus p1 power 3, and you will go up to alpha 1. And in the second bracket you will go up to alpha 2. In the third you will go up to alpha 3, and similarly in the last bracket you will go up to alpha k. Okay, so by binomial I can say that this will be p1 power alpha 1 plus 1 minus 1 divided by p1 minus 1. Now this will be p2 power alpha 2 plus 1 minus 1 divided by p2 minus 1, and similarly this will be pk power alpha k plus 1 minus 1 divided by pk minus 1. So you can use this formula to find out the sum of all the divisors. Now an example can be, if I want to find out the sum of all the divisors of 12, then 12 is 2 power 2 into 3 power 1. So basically I will write 2 power 0 plus 2 power 1 plus 2 power 2 into, I will start from 0 and I will go up to 1 in the power of 3. So here you can see that whenever one term of this is getting multiplied by one term of this, you will get one divisor. If 2 power 0 is multiplied by 3 power 0, I will get 1, that is one of the divisor. If 2 power 0 is multiplied by 3 power 1, I will get 3, that is again another divisor. If 2 power 1 is getting multiplied by 3 power 0, that is 2, that is again one of the divisor. So whenever two terms of this brackets will get multiplied, you will get one divisors. So if you multiply these two brackets, basically you will get the sum of all the divisors. So the sum of divisors will be given by this, and this we can find out by using this formula, that is 2 power 3 minus 1 divided by 2 minus 1, and 3 power 1 plus 1 minus 1 divided by 3 minus 1. So the total number of the sum of all the divisors will be given as 28. You can find it out by opening the two brackets also. Here you can see that each number is one divisor. So there are 6 divisors that are possible, that we have already seen, and if I take the sum of all these 6 divisors, I will get 28. Now if I want to find out the number of ways of putting n as the product of two natural numbers, if I have 12, I can represent 12 as 3 into 4 also, and I can represent 12 as 2 into 6 also. Even I can represent this as 1 into 12 also, right? So then in how many ways I can represent this 12 as the product of two numbers, as the product of two natural numbers? If I want to find out that, then that will be given by this formula, that is half of a1 plus 1, a2 plus 1, ak plus 1. So this is nothing but number of divisors by 2 if n is not a perfect square. If this number is not a perfect square, then it will be given, then the number of ways of putting n as a product of two natural numbers will be given by number of divisors by 2. And if n is a perfect square, suppose if I want to count for number 25, that is a perfect square. So for that I will use this formula, that is number of divisors plus 1 divided by 2. So this two formula you should remember. Now we will consider one example, and in this one example I will explain you everything, all the parts. That is, consider a natural number of this form, that is 2 power 5 into 3 power 4 into 5 power 7 into 7 power 2. If I want to find out the total number of divisors, that will be given by 5 plus 1 into 4 plus 1 into 7 plus 1. I will increase all the power by 1 and then multiply into 2 plus 1, which again will be given by 720. If I want to find out the total number of proper divisors, then I will subtract 2 from 720, because I will subtract 1 and the number itself. If I want to find out the number of odd divisors, then it can be obtained by choosing from only this divisors. I cannot take 2. If I take 2, then it will become even, so I will exclude this 2, so I will not take 2. So if I choose from this 3 numbers, 3 power 4, 5 power 7 and 7 power 2, I will get all the odd divisors. So number of odd divisors will be given by 4 plus 1, 7 plus 1 into 2 plus 1, that is 120. Now if I want to find out the total number of even divisors, one thing what you can do is, you can take the total divisors and you can subtract the odd divisors, so you will get all the even divisors. That is one method. Or the other method is you can take at least 1 2. At least 1 2 you will have to take. So at least 1 2 will be given by 5. So either you can take 1 2 or 2 2s or 3 2s or 4 2s or 5 2s. So it will be given by the number of ways of taking 1 2 is 1, number of ways of taking 2 2 is 1, number of ways of taking 3 2s is 1, 4 2s is again 1, and 5 2s is again 1. So the total will be 5. Okay, so 5 into 4 plus 1 into 7 plus 1 into, for 3, 5 and 7 you have to take 0 or more, but for 2 you have to take at least 1. So that will give you the total number of even divisors. Now the fifth part is number of divisors divisible by 5. If I want to find out number of divisors divisible by 5, that means I will have to take at least 1 5. If I have to take at least 1 5, I will not add 1 to the power of 5. So I will get 5 plus 1, 4 plus 1, 7 into 2 plus 1, that will be 630. If I want to find out the total number of divisors divisible by 10, then for that I will need at least 1 5, and also I will need at least 1 2. If 1 5 gets multiplied by 1 2, I will get 1 10. So I will need at least 1 5 and I will need at least 1 2 for the number to be divisible by 10. So I will take at least 1 2 and at least 1 5. So I will not add 1 to the power of 5 and to the power of 2. So 5 into 4 plus 1 into 7 into 2 plus 1, that will be 525. Now if I want to find out the number of divisors divisible by 2 but not by 4. So divisible by 2 but not by 4 means you need exactly 1 2. So out of a group of 5 2's, you need exactly 1 2. So number of ways of taking exactly 1 2 out of 5 identical objects will be given by 1. So number of ways of taking 2 is only 1. So 1 into 4 plus 1 into 7 plus 1 into 2 plus 1, which is equal to 120. If I want to find out the sum of the divisors, then that will be given by 2 power 0 plus 2 power 1. I will go up to 2 power 5. Here I will go up to 3 power 4. Here I will go up to 5 power 7, and here I will go up to 7 power 2. Now you can use this formula to calculate the values of this 4 brackets. So that will be given by 2 power 6 minus 1 divided by 2 minus 1, 3 power 5 minus 1 divided by 3 minus 1, and so on and so forth. So you will get the sum of all the divisors. Now if you want to find out the sum of only even divisors, that means you will have to take at least 1 2. So you cannot write 2 power 0 here. So that case will be rejected when you are taking no 2. So either you will take 1 2, or you will take 2 2's, or you will take 3 2's, or you will take 4 2's, or you will take 5 2's. 2 power 0 is excluded because you have to take at least 1 2. So you will get the sum of, if you will simplify this, you will get the sum of all the even divisors, because here we are taking at least 1 2. Now if I want to find out the sum of all the odd divisors, then no 2 should be selected. So I will exclude 2. So I will write 3 power 0 or 3 power 1. So either 0 3 or 1 3 or 2 3, and I will go up to 3 power 4. And in 5 I will start from 5 power 0, 5 power 1, and I will go up to 5 power 7. And in 7 I will write 7 power 0 plus 7 power 1 plus 7 power 2. Now this you can simplify by using the formula. If I want to find out the sum of divisors of the form 4n plus 2, now what is this form 4n plus 2? 4n plus 2 will imply even number but not divisible by 4. This is an even number since it is something of this form 2k. So this is an even number but it is not divisible by 4. So we will need exactly 1 2. So I will write 2 power 1. All other cases will be rejected. Only 2 power 1 into the cases when 3, 5's and 7's will be selected. So you will have to take exactly 1 2 if the number is of the form 4n plus 2. And the last part is the number of ways in which n can be resolved as a product of two divisors. So n is not a perfect square. You can see that n is not a perfect square. So in this case, what will be the number of ways of doing so? The number of ways will be total number of divisors by 2. So total number of divisors were 720. So 720 by 2 is 360. So the number of ways in which n can be resolved as a product of two divisors will be given by total number of divisors by 2, which will be equal to 360. So students, through this one example we have seen how questions can be asked in 12 parts. I hope you like this video. Our next topic will be distribution of alike objects. So stay tuned. Have a nice day. Thank you.